So we are back once more with the tutorial in Rust. We are on a third video right now, and we went through this tutorial point. Last video was data types. Basically, we also talked about variables in more general context, and of course the constant. Sorry. And now we also came over the one called string. Now we're going one step ahead. And we're gonna basically do a video about decision making, but before we can do that, we need to talk about operators. So we're gonna continue this video here about operators. And there are different kind of operators in Rust. Typically, there are in programming languages. There are the arithmetics one, the bitwise, comparison, logical, bitwise again, and conditional. I don't know why they did two of them. It's probably just a flaw on the website. From what I usually say is, if you're doing primarily web stuff, you might not use these kind of operators as much if you're creating stuff like, APIs and stuff that do algorithmic stuff. I wouldn't consider doing CRUD operations on a website as per like algorithmic stuff. It's more like create, read, update, delete, and that's really what this is all about. So since this is a console application tutorial for now, I'm gonna focus on more or less all of them, and the examples I'm gonna provide will probably be handpicked by me. So we're gonna continue downwards here, and there's a small page about arithmetic operators using the plus addition, the subtraction, multiplication, division, and modulus. It's pretty normal stuff. Nothing crazy here. It is the same thing. We can just go in here, take any, print line, and just remember the exclamation mark like that, and say 5, 10 modulus 2. It should give us like 5 or something like that, I think it is. No. Oh yeah, we need to have this format, and we are being bashed because we forget about these kind of things. So we give 10 modulus 2 is 0. It is the first one I'm probably thinking about. 2. All right, so it is the same way it works. I usually get this confused in my head, so we can just try some other operators like division. So that should give 0. So let's reverse it. So we have 5 is what I thought about division when I said modulus, and it is remainder value, not division. So that was my flaw. I can also do stuff like, multiplication. It's pretty boring, and it is basically just, going through them and seeing if there's any difference. But, we can see that there is nothing. It's the example show what this is all about, and nothing really crazy goes on. We do not have the plus plus and the minus minus operators in Rust. So, for example, if you created a variable, let's say let's and called it I equal to 0, and we then would go ahead and print out I right there. We get 0 because it's inset to 0. Then if you settle for AI plus plus, just like that in the old editors, well, we cannot do this, languages, so we can say I equal to I plus 1. That would basically create the same operation, and it wouldn't actually allow that because we learned we need to do it with a mod in front of it, so we need to make it mutable, and now we have 1. So next time we call the same sentence again here, we will see it becomes 2, and so on. In this particular case, it would be better for us to create a function, for example, that would increment the variable of I for us. But all this is just mere learning the language. We shouldn't code like that in reality. In reality, we should find a way to control the value of I in a much more smooth and beautiful way. But for now, we're just learning the language, going through stuff. We are definitely remembering to use the word mod, which is exactly how you would learn a new language if you paid attention to the tutorial and you also paired that with some practical approaches like this. So let's go back one more time. This irritating fly around my face. I want to kill it. Wherever it is, go away. Um, so the next one here is called the relational operators. It's another group, and it is basically the same. I don't see, yeah, I don't see any funky operators. For example, some languages support the three equal signs, which is the comparison of a type and an equality at the same time, where in this particular case we only have one set of equal, which is double equal signs, which is nice. So we have normal ones here, not really that interested, but we could do stuff like, for example, let's create a variable called, let's call it a, and then another one here called let b 1. And then we could do stuff like a not equal to b. Let's see if it allows this syntax. And it says true. So this is a kind of the question we ask. And you should always understand the operators, relation operators as questions. So you're basically saying, well, a is not equal to b, right? And then you're giving the answer right there, which is true. And if I set that to a 1, then it would say false, because we are double negativing, well, we're reversing the result of being true. And that is what the exclamation mark basically means. So I see nothing crazy here. We should basically just be aware of that the operators for arithmetic operations and relational operations are the same. Operators are the same. So going to logical, which is something we usually do when we do decision making. So you go ahead and say, for example, A and B, and that will result in something, but since we cannot do that, it's a it's not as much a question anymore. It's more like a way to combine a conditional way. So that would usually be done in a if statement in parentheses, just like this, and then it would be ran. I don't think it's gonna accept this. No, it will not. So if we had a decision-making if statement here saying these two, they would be bound together and both would have to be true. So if the question would be equal 1 and equal 2, I think this should definitely work. It would say false, because then we're basically saying, is A equal to 1? Well, it is. And is B equal to 2? Well, it is not. So false is a heavier weight compared to true because of the ampersands. If we went to the or, for example, like that, we would reverse it to being true, because then we are saying either this or that needs to be true. This is exactly the same way it works. Also, the not operator is here, so we could reverse saying if it's not larger than or equal to, which is a nice addition. The bitwise operators is a bit more I'm gonna be honest, I usually don't use these. People might say something about this. I think it's a matter of what kind of task you've been doing. But there are also these operators which are nice if you wanna perform different kind of bitwise operations. For example, the ampersand standing alone performs a Boolean AND operation, and you can basically, see different kind of examples of how it works, but it's not really that interesting, I would say. So in this particular tutorial, we're going to go to the decision making part here, and we are saying this decision tree right here, or decision diagram, where we say the condition is either this and that, and we can go to if it's false or if it's true, and then we can go to a certain path and do something. So they support if, else, and else if, and then there's a match. So let's go ahead and check out the syntax. So they do allow us to say if some kind of Boolean expression. So if I go in here and say in my code, let's just, for this particular case, say if a equal 1, and how was it the syntax again? It's just doing these. Then I want to print line. I want to say that a is equal to 1. And we can run this program right here, and we will then get a warning because of unused variable b, which is great. And it does also say a is equal to 1 because it is. So this is a way of us to use the if statement. We can also see that it kind of allows the else. So we can say like if it's equal to something, else would default to that. So we go ahead and just check out if everything is the same. And of course it is, but a is not equal to 1. So let's equal a to 22. And we're going to see that a is not equal to 1, which is true in this particular case. It also supports the, was it the simple if else? Oh, it's just the same syntax. And the nested one, it's going to be the else if, so we can go ahead and add on like this, else if a is equal to 2, and then do the syntax just like that. Just, whoops, not look at the microphone so much because I cannot see anything. Let's get the syntax great. So we're gonna say, and then we're gonna print out like that, print line. And we're gonna go ahead and print out a is equal to 2. And did I did. So we can go ahead and do like a 2 there, and then it's now equal to 2, and we can have it as 1. It's equal to 1, and we can have it like to some other weird number. And now it's not equal to 1, so a is not equal to 1, which is that, statement there. So it will be the same, and we can nest it even as much as we would like. Now they do have something called a match statement. That's something new. I haven't really heard about that. It checks if the current value is matching from a list of values. It's very much similar to the switch statement. So this is kind of a similar thing to switch. In the first place, notice that the expression follows the match keyword. It does not have to be enclosed in parentheses. So we can check it out and see that we have a form of syntax saying, well, have a variable with some sort of expression result. Well, it's the name of the variable. And we say match. That's a keyword for the functionality. And then we say the variable expression, which will be the thing we match it up against, it would seem. And then we have constants, which are literal values pointed towards some sort of statement. That does seem a bit weird. Let's look at it down below. So it kind of say found match for MH. State name is Maharashtra, whatever. I cannot pronounce that. So we can put our, and now it makes sense, expression statement right here. So we can go ahead and say, this is the, I would call these associate matches. So we match on the associate or the name of, it's a named array. Usually when you have arrays in languages, you have the numeric arrays, then you have the named, associate arrays. That way you can match on a given, name of a variable. Instead of the index 0, it could be MH, for example, which would be easier if it were like you were matching up against languages, or countries, stuff like that. It could then be DK for Denmark or US for United States of America. So that would be easier that way to to find in a list. So I don't think I need to particularly like this. I see the force in this. I was never a great user of switch statements in other languages. I used it sometimes. I would say I used it mostly in Java when I created, factory patterns or other design pattern stuff. But just in all reality, it's a thing, right? You have to get your feel of how you like to write your code. And I know there is a given convention in all languages. For example, in what is it like the React Native app language, where you write React Native, there is like a functional programming approach which is kind of standard, but you don't have to do that. You can basically write normal JavaScript code if you would like to do that, but it's kind of looked at differently. And I just want to say, compared to that, it also seems that there might be some sort of way to write your Rust code. So yeah, I just want to say that I haven't found it yet, but there probably is. I want to say that. So we can go back here and say, how much can we do right now in Rust? Well, we can create functions. We can create variables, different types. We can write our decision making stuff on static variables. We have no way at the moment to take input. Just going through this, there's something called input here down below. Also the file input. So at some point in time, we're going to get some input. Maybe we're going to sneak to that a bit before to do something, because I feel we need to do a small project soon. But we need to do a few more of these videos before we do that, because we need to understand more than just decision making. We also need to understand loops and functions. And I guess tube arrays probably pretty darn important as well to know something about. Then we should definitely go ahead and try and create a small program that could take input, and from that, give us different kind of other inputs, so we can choose something from a menu structure and so on. It's a typical small project. I wouldn't necessarily say this first project would be the aim of beautiful code, but more like the aim of doing something interesting with the language that will kind of collect some of the things we already learned. So I want to say, for this video, we tackled decision making and operators, and next one is going to be loops, and we're going to talk about that in the next video. And I want to say, if you're not already subscribed to this channel, please go ahead and just subscribe. It is free, it doesn't cost you anything. It would help me, grow the channel. Basically, that's what I'm here to do. And I will also probably be making 0.1 cent extra per week if you subscribe, and at the end of the day, everything will add up and you will help me that way, which is free. So just go ahead and click the button if this is what you really want to do, and click the notification bell so you get notifications whenever I upload a new video. So see you again online, have a really nice day, and looking forward to the next video.